Hello, hi. I hope everybody is doing okay. Let's do another example of checking the solution. So again, a differential equation is given, and in this case, they give you two functions, y1 and y2. And we need to check that each one of them is a solution. So I'll actually do y2 because that is the more complicated one, and you can try y1 by yourself. So let's check that the function y2 is indeed a solution to this differential equation. Now this one is t is bigger than 0 is that we drop the absolute value for the ln of t. So if I don't have any restriction on t, we should actually write it down the ln of absolute value of t. Remember, ln cannot take a negative number or 0, right? But because t is bigger than 0, we can drop the absolute value. Don't worry too much about that. So let's start with y2. I'm simply going to write y2, but of course y2 is a function of t. Now I have to substitute this y2 into this differential equation and make sure that this equality is true, right? So I have to take the first derivative and the second derivative because I see y double prime, right? So I have to do that. So let's go ahead and do this. So each time we have to use the product rule. So let's do the first derivative, y2 prime. So it's the product rule. So I copy the first one, multiply by the derivative of the second, plus I take the derivative of the first, multiply by the second function. So that's the product rule. So let's simplify that. So the derivative of ln of t is 1 over t, or t to the power negative 1. Same thing. Plus the derivative of t to the negative 2 is negative 2t to the power negative 3. Remember, the derivative of t to the n is n t to the power n minus 1, right? So you subtract 1 from the exponent, right? And of course, you multiply by ln of t. So this I copy. So let's simplify that before I take the second derivative. So let's simplify. Remember, when you multiply, you add the exponent. So I get t to the power negative 3 because negative 2 and negative 1, when I add, I get negative 3. This positive and negative, I can just write negative here. 2t to the power negative 3 times ln t. So that's my first derivative. I need one more. Let's do the second derivative. So I need a little bit of space, so I'll start from the left. So start from the derivative of t to the power negative 3. So that will be negative 3 t to the power negative 3 negative 1, right? So that's actually negative 4. Minus this minus sign. I'll put a parenthesis. Whenever I have a minus sign, it's better to put a parenthesis because that negative sign goes with the whole thing. So it's always recommended to put a parenthesis so you avoid making mistake with the sign. Now here I use the product rule. So you're thinking this as one function and that's the other one. So let's do that. So let's copy the first function, multiply by the derivative of the second function, plus now I take the derivative of the first function, multiply by the second function. So let's actually go ahead, work it out. So this is y2 double prime. So let's actually take the derivative now. So it's 2t to the power negative 3 I copy. The derivative of ln of t is 1 over t. Or I'm going to actually write t to the power negative 1. So let's actually do that. Plus, now the derivative of 2 times t to the power negative 3 is negative 6, because you multiply negative 3 and 2. So I get negative 6 t to the power negative 3 negative 1, which is negative 4, times ln of t. So let's simplify out. So I get negative 3 t to the power negative 4. Let's distribute this minus sign. And remember, this positive and negative, that's actually negative, right? So let's start with the first one. So I have, when I distribute that, I get negative. And of course, when I multiply, I add, right? So I get 2 t to the power negative 4, because negative 3 and negative 1 is negative 4. And then I have negative times negative. So that's actually positive. So do not forget, you multiply negative times negative. So that's positive. 6 t to the power negative 4 times ln t. I see like term, so why not we combine the like term? So let's do that. So I get negative 5 t to the power negative 4 plus 6 t to the power negative 4 ln of t. So now I have the second derivative. So now let's go ahead and substitute into this differential equation. So that's my differential equation here. So I'm going to go ahead and copy the differential equation. Let's actually take a screenshot of the differential equation and let's just copy it down below. Okay, so let's do it here. Let's see. So I have, so in place of y double prime, I'm going to substitute this, my y2 prime. In place of y prime, I'm going to substitute my y2 prime, which is this. And in place of y, I substitute the y. My y is actually y2, this one. Okay, so let me actually circle them. So this is my y2, that goes in place of y. Sorry. Uh, this is my y2 prime. This goes in place of y prime. And this is my y2 prime, that goes in place of y double prime. Okay, so let's do that. Okay, so let's do that. So I'm going to write t square times, in place of y double prime, I write y2 double prime, and that is this one. So let's do that. Negative 5 t to the power negative 4 plus 6 t to the power negative 4 ln t. Continue, plus 5t y prime. Now let's substitute my y prime. That's my y2 prime. So let's do that here. My y2 prime is this, t to the power negative 3 minus, so t to the power negative 3 minus, so make sure we copy it correctly, 2 t to the power negative 3 ln t. 2 t to the power negative 3 ln t plus 4y, plus 4y. But what is my y that goes here? My y is y2, remember? So let's go and make sure what is my y2. My y2 is t to the power negative 2 ln t, t to the power negative 2 ln t. And we want to make sure this equality is true. So I need to make sure this is true. So that's a question mark, right? I have to make sure. So everything on the left hand side should give me 0. So there should be a lot of cancellation and everything will be 0. Let's check it. So of course I have to multiply out. So that's negative 5 t to the power negative 2, right? So you add the exponent, negative 4 plus 2. So that's negative 2 plus 6 t to the power negative 2 ln t. Continue multiplying out here, plus 5 t to the power negative 2. Remember, there's invisible 1. So when I add negative 3 plus 1, I get negative 2. I multiply with this one, I get negative 10 t to the power negative 2 ln t plus 4 t to the power negative 2 ln t. Is this equal to 0? That's the question. First of all, you can see that the negative 5 t to the power negative 2 and positive 5 t to the power negative 2. So that's cancelled. Everything else is a like term because all of them has t to the power negative 2 ln of t, right? So the t to the power negative 2 ln of t, that's a common. So if you factor out, so if I factor out t to the power negative 2 ln t, what is left? So from here I get positive 6, negative 10, plus 4. So all I did, I factor out t to the power negative 2 ln t because that's a common factor. And once I get that, this is in fact 0. And 0 times anything is 0. So I do get 0, and which match with my right hand side. So indeed, this is a solution. Remember, you can do it. Bye bye.